When it comes to sound waves, there are three characteristics that are important: loudness, pitch, and quality. When it comes to loudness, loudness is for waves amplitude. So a wave like this is not very loud when it comes to sound waves. And a reminder, sound waves aren't actually transverse waves. They're longitudinal waves. They look like this, where the wave is spread apart and called a rarefaction, or close together called a compression. But because this is difficult to draw, we use a transverse wave to represent a sound wave. So this loudness, the amplitude here is small, so it's not very loud. This would be the same wave, but much louder, because it's got a greater amplitude.
Here we have a wave of a certain amplitude that I'm going to call A. And if we consider a very similar wave that has the same wavelength, but maybe a different amplitude, so maybe half the amplitude, and this is quite a tricky thing to draw during a sine wave, but it's worth practicing. That's not bad, is it? If this other wave has an amplitude of half of the other one, we can look at the difference in the intensity or the power of these two waves. Now, the intensity of an object is a measure of the amount of energy per second per square metre. So the intensity is equal to power over the cross-sectional area. So if we think about intensity, I maybe have the light on a phone. Now if I shine it if I put all of that energy onto one small area, it's going to be quite an intense brightness. As that energy is spread out over a larger and larger area, we can say that the intensity of the light is going to be less and less. So the intensity equals power over area. And actually what we find is that the intensity isn't proportional just to the amplitude.